Many Linux computers do not run a firewall. Is your computer one of them? Let's find out. We have the Linux server or the Linux desktop on the left and just a regular computer on the right. So let's scan this computer for any open ports, anything that's been left open. It could be that it's running web server, an SSH server, maybe it's running NFS, file sharing, all kind of things could be running on the computer that put the gates wide open or the doors, so-called ports, wide open on the computer. Let's scan the computer. To do that, we use a tool called Nmap, and we scan the target computer. So we scan it using its unique internet address. In this case, this is the unique address for this computer. Scan it, and this is all it takes. It will scan the computer for anything that's been left open. So you'll see, in this case, we have two things left open. We have an SSH server running, an SSH service, and a web server, an HTTP service. So obviously, this computer is running things which could be a potential way for hackers to get into the computer. To block unwanted network connections and unwanted ports from being open, you can use a firewall. A firewall lets you control that, which network connections are allowed to the servers and which are blocked. As in this image, you see a regular user and it goes through the firewall before it reaches the Linux server. So the Linux server or the firewall typically runs inside the Linux server, but it can also be outside. Both are possible. Inside you would call it a host firewall, and outside it's a network-based firewall. So given the firewall, you can block all network traffic and only allow specific network traffic, or you can configure it as you want. So let's take a look. So let's configure this firewall. We type sudo ufw reset, that resets all the rules. If we press enter and click yes, you'll see all the rules are removed. And now we can set some default rules. So we can say, for example, by default, allow outgoing traffic. So it's the default, allow outgoing, any connection going out from the computer. And let's say we, by default, deny incoming. So it's a very typical firewall setup. Then let's say we want to allow port 22 for remote access. Or if you want, you can type SSH, use the same as for remote access. If you run a remote server that is not in your physical location, you want to remotely log in, which you typically do using SSH. Now, of course, if you don't run SSH, you can disable that. And let's say we deny the port 8000. We'll enable the firewall rules. Now, besides this, maybe you also want to allow DNS or port 80. Okay, let's enable this firewall. So the firewall is now running. Let's see, we configure the firewall, and if you do a scan with the computer, let's see, it takes a second. And now port 22 is open, we allowed it. Port 8000 is open, but is closed. Or sorry, port 80, and port 8000 is gone because we block it in our configuration, in our firewall. Now that doesn't mean that the program is not running anymore, simply that the firewall blocks that connection. The firewall is configured. You see with the status command, we can find out it's configured. It's denying any incoming traffic. So you might think this Linux computer is now secure because the firewall is protecting it. So let's put that to the test. We have a malicious script here, reverse.sh. I'm going to start a listener on this computer and then run this script. And you'll see the hacker here instantly got access into this computer. You'll see it changed from his computer to the victim's computer. So we bypassed the entire firewall as a hacker on this computer, and we got into this computer. So how does that work? Well, on the firewall, we are denying incoming traffic, but we are not denying anything outgoing. So what an attacker could do is start a listener on the cloud or on their own computer and make the victim computer, using a bash script, connect to their computer and provide a shell that gives them complete access into the computer. So you'll see we can actually access the same firewall configuration because we are in the victim's computer as a hacker. The hacker could connect to the computer simply because the user ran a malicious bash script. You see the hacker instantly got access into this computer, the primary computer, from his own computer. So how is this possible? We are running a firewall. So what happens here is we're using the outgoing connection 4242. If we check the firewall, You see, we are denying any incoming traffic, which is typically what people configure, but they don't keep too much attention on outgoing traffic. Now, outgoing traffic can be used by a hacker to gain access into a computer. This is called a reverse shell. So instead of the hacker connecting to your Linux server, it makes it that your Linux server connects to their computer and provides a shell, so-called reverse shell. So it goes in the other direction, and it allows them to control the computer remotely. So you want to be sure to not just blindly allow any outgoing traffic. You want to deny specific traffic as well. You can say sudo uw deny out to any, and then let's say we want to deny this port 4242. So let's say we deny outgoing to this port 4242. We enable the firewall. So let's see what happens. Again, the hacker now starts the listener, and let's say the user runs the malicious script, and you'll see nothing happens. We now blocked this specific port, so this attack no longer works. So it's important to only allow outgoing traffic that you actually want to use, because blindly allowing any outgoing network traffic, it could allow the door to be open for an attacker, for a hacker into your Linux server.